Picture this, a faint, flickering glow in the vast darkness of space, trillions of miles away, captured by the most powerful telescope humanity has ever built. The James Webb Space Telescope, a marvel of modern science, has turned its golden mirror toward Proxima Centauri b, the closest exoplanet to Earth, and what it found has left astronomers speechless. Strange, pulsating lights, unlike anything we've seen before, shimmer on its surface, sparking a question that has haunted humanity for centuries. Are we alone in the universe? These aren't just random glimmers. They're patterns, almost like the distant glow of a city seen from an airplane at night. Could this be the first glimpse of an alien civilization? Buckle up, because we're diving into the heart of this cosmic mystery, exploring what these lights could mean, how they were found, and why they're rewriting everything we thought we knew about life beyond Earth. Let's set the stage. Proxima Centauri b, or Proxima b for short, orbits the red dwarf star Proxima Centauri, just 4.2 light-years away. That's about 25 trillion miles, a distance so vast it's hard to wrap your mind around. This planet, discovered in 2016, is a rocky world, roughly 1.3 times Earth's mass, nestled in the habitable zone, where liquid water, the key to life as we know it, could exist. But Proxima b is no Earth twin. Its star, a dim, fiery red dwarf, bombards it with intense radiation. One side of the planet, tidally locked like our moon, bakes under constant daylight, while the other freezes in eternal night. It's a harsh, alien place, yet something about it has always intrigued scientists. Could life, even in such extreme conditions, find a way to thrive? Enter the James Webb Space Telescope, humanity's sharpest eye on the cosmos. Launched in 2021, this $10 billion masterpiece orbits 1,000,000 miles from Earth, peering into the universe's deepest secrets. Its infrared vision can pierce the darkness, picking up the faintest traces of light and heat from distant worlds. Unlike other telescopes, Webb can see through cosmic dust, analyze planetary atmospheres, and detect signals that others miss. When astronomers pointed it at Proxima b, they weren't expecting to find much, just data on its atmosphere, maybe hints of water vapor or methane. But what they got was a curveball, unusual, rhythmic bursts of infrared light emanating from the planet's night side. These weren't the steady glow of reflected starlight or the heat of volcanic lava. They were structured, almost deliberate, like the pulse of a distant beacon. Now, let's pause and think about what this means. Lights on the night side of a tidally locked planet, 25 trillion miles away, aren't something you just shrug off. On Earth, city lights glow at night because we've built sprawling urban centers powered by electricity. Could Proxima be home to something similar? The idea sounds like science fiction, but science is full of surprises. Astronomers like David Kipping from Columbia University, who studied Proxima b's quirks, describe it as a tricky world. Its infrared signature doesn't match typical rocky planets. Most planets absorb sunlight and emit steady heat, but Proxima b's signal is erratic, almost like it's reflecting or generating light in ways we don't fully understand. Could these lights be artificial, the work of an advanced civilization? Or is there a natural explanation we haven't cracked yet? Let's explore the possibilities. First, the natural ones. Proxima b orbits a volatile red dwarf star that unleashes powerful solar flares. These could interact with the planet's atmosphere, if it has one, to create auroras, glowing curtains of light like Earth's northern lights. Another possibility is geological activity. Volcanoes or reflective surfaces, like vast crystal deposits or liquid pools, could scatter light in unusual ways. Then there's the chance of instrumental error. The Webb telescope is incredibly sensitive, but space is messy. Cosmic rays, starlight interference, or even data glitches could mimic a signal. Scientists are meticulous, double-checking every pixel of data to rule these out. So far, the lights persist, defying easy answers. But what if? And this is the big what if, the lights aren't natural. The idea of an alien civilization on Proxima b is thrilling, but it's not as far-fetched as it sounds. Imagine a species adapted to the planet's extreme conditions, perhaps using vast solar arrays to capture Proxima Centauri's energy on the scorching day side and channel it to the dark side for warmth and power. These arrays could reflect light or emit infrared signals as they operate, creating the patterns Webb detected. Or maybe they've built shielded habitats, glowing with artificial light to sustain life in the eternal night. On Earth, we've seen extremophiles, bacteria thriving in boiling vents or acidic lakes, proving life can endure the unimaginable. Proxima B, with its potential for liquid water, could host something far more complex, maybe even intelligent. Let's back up and talk about how Webb made this discovery. The telescope's infrared instruments are like cosmic detectives, sniffing out clues in wavelengths invisible to the human eye. Proxima B's 11.2-day orbit around its star creates a cycle of day and night that Webb can track from Earth. By observing the planet at different points in its orbit, scientists can map its thermal emissions, essentially, its heat signature. When Webb focused on the night side, it picked up spikes of infrared light that didn't match the expected cold, dark profile. These spikes were rhythmic, almost like a heartbeat, suggesting a source that's active, not passive. To confirm this, astronomers used Webb's spectroscopy tools, which break light into its component wavelengths to reveal chemical fingerprints. The data hinted at unusual compounds, but nothing definitive yet. The lights remain a puzzle, but they're real enough to keep scientists glued to their screens. Now, let's address the elephant in the room. Could this really be aliens? The search for extraterrestrial life has been humanity's obsession for decades. The SETI Institute, founded in 1984 by astronomers like Jill Tarter, has scanned the skies for radio signals from alien civilizations, so far finding nothing. But radio waves are just one way to look. Light, especially artificial light, is another. A 2021 study suggested that Webb could, in theory, detect city-like illumination if it's bright enough and spectrally distinct from starlight. Proxima B's lights fit that profile, narrow, intense, and unlike anything natural we've seen. If confirmed, this would be the holy grail of astronomy, proof that we're not alone. But confirmation is the key word. Scientists are cautious, knowing that extraordinary claims require extraordinary evidence. What makes Proxima B such a tantalizing target? It's not just its proximity. As the closest exoplanet, it's our best shot at studying a potentially habitable world up close. Its habitable zone position means liquid water could exist, especially at the twilight zone between day and night, where temperatures might be just right. But Proxima Centauri's flares pose a problem, blasting the planet with radiation that could strip its atmosphere. Without an atmosphere, Proxima B would be a barren rock, its day side scorching and its night side frozen. Yet, if it has a magnetic field or a thick atmosphere, it could retain heat and water, creating pockets where life might cling on. The lights Webb detected suggests something dynamic is happening, whether it's geological, atmospheric, or, dare we say, technological. Let's zoom out and think about the bigger picture. The universe is vast, with trillions of planets orbiting countless stars. Since the first exoplanet was confirmed in 1992, we've found over 5,000, and that's just scratching the surface. Red dwarfs like Proxima Centauri are the most common stars, and many host planets in their habitable zones. If life exists on Proxima B, it could mean the cosmos is teeming with it. The discovery of these lights, even if they're not artificial, is a wake-up call. It tells us our tools are finally sharp enough to probe the secrets of distant worlds. Webb is just the beginning. Future telescopes, like the Extremely Large Telescope, set to launch in 2028, will dig deeper, analyzing atmospheres for gases like oxygen or methane that could hint at life. But what if the lights are artificial? The implications are staggering. An alien civilization, even one long extinct, would mean life isn't a fluke confined to Earth. It would raise questions about their technology, their culture, and their survival in such a hostile environment. Could they be watching us, aware of our primitive telescopes? Or are these lights the remnants of a society that flickered out millions of years ago, their cities now silent ruins? The human mind races with possibilities, but science demands patience. NASA and the global astronomy community are now prioritizing Proxima B, planning more Webb observations to map the light's patterns and spectra. They're also exploring ways to block Proxima Centauri's glare, using star shades or coronagraphs to see the planet more clearly. Let's not forget the human side of this story. For millennia, We've looked at the stars and wondered if anyone's looking back. From ancient myths to modern SETI searches, the quest for cosmic company has shaped our culture and science. The lights on Proxima B, whether natural or not, are a reminder of how far we've come. 20 years ago, we barely knew exoplanets existed. Now, we're spotting potential signs of life on a world 25 trillion miles away. That's a testament to human ingenuity, from the engineers who built Webb to the astronomers decoding its data. But it's also a humbling moment. If those lights are artificial, they've been shining for eons, waiting for us to catch up. So, where do we go from here? The next steps are already underway. Webb will continue observing Proxima B, refining its data to pin down the light's source. Scientists are modeling possible explanations, from exotic minerals to atmospheric phenomena, while keeping an open mind about artificial origins. Ground-based telescopes, like the Allen Telescope Array, are listening for radio signals from the Proxima system, just in case. And in the coming years, missions like Breakthrough Starshot, which aims to send tiny probes to Proxima Centauri, could give us a closer look, if we can solve the engineering challenges. For now, the lights remain a mystery, a cosmic riddle that's captured the world's imagination. Let's wrap this up with a thought. Whether these lights are the glow of alien cities or the flicker of natural forces, they're a call to keep exploring. The universe is vast, strange, and full of surprises. Every discovery, from the first exoplanet to the lights on Proxima B, pushes us closer to answering the ultimate question: are we alone? For now, the answer is still out there, twinkling in the infrared, waiting for us to find it. What do you think these lights could be?